Alrighty, so 3.3. We're going to start working with truth tables now, okay? And what you need to know is that depending on the type of thing you see, the truth table can be very simple or it can get kind of involved, but it all should make logical sense. That's why this unit is called logic, okay? So let's go ahead and start filling in some things here. So if we just have one simple statement, okay, this is how you interpret this. Let's say P represents it's rainy outside, okay? We can now say whether or not that's true, okay? So just by looking outside, we would say, you know what, that's false, right? Or maybe it is drizzling, I don't know. But one way or the other, it either is or it isn't, right? So if I were to negate that, if the statement were originally true, now it would become false. And if the statement was originally false to start, now it's going to become a true statement. I think that should make sense, yes?
Yes.
Okay. And I think I just filled in your table down here. Okay? So this is your first definition for a truth table, just a simple negation of one statement. Okay? Now, the next one is when we have a conjunction, and you do need to know this word and what it translates to. What's a conjunction translate to? What word is that? And. That is correct. Okay, so even if it helps, on this side, if we do a conjunction, you might even, at least for this first one, write it out in words. P and Q. Okay? And so now let's look at the statement. So if P is I got an A in English, and Q is I got an A in math, okay? How do we interpret that? If we have an and statement, and I think we talked about this before, right? In order for the statement to be true, this one, right? What must happen? Okay, let me rephrase. So if P is I got an A in English, and Q is I got an A in math, and let's say each row represents a particular, a student that actually had those things happen or they didn't. Student number one, the T represents they did get an A in English, and the T here represents that they actually did get an A in math. So would him saying I got an A in English and I got an A in math be true?
Yes.
Yes. You guys see how that works now? Now, if I go here, let's say student B actually did get an A in English, but he did not get an A in math. And he goes out and says, I got an A in English and an A in math. Would that be a true statement anymore? No. So now I'll re-ask the question. In order for an and statement to be true, what must happen? Both of them have to be true. Does that make sense? So these other two are false as well. And here it is, nice and typed out for you. This is the truth table for a conjunction. In order for it to be a true statement, both parts of the statement have to be true. Okay? Any questions so far? All right, let's look at the next one, which is disjunction. Same scenario. This will help us understand how to fill it out. Remember that when we use the word or, it means one or the other, or even both. Okay? So like if I said tomorrow, I want you guys to bring a pencil or bring a pen. You guys with me? And half of you bring pencils, half of you bring pens. Did you meet the requirement?
Yes.
Yes. What if a third bring pencils, a third bring pens, and a third bring both? Did you all meet the requirement?
Yeah.
Yes. Does that make sense? So just from that argument here, going back to the I got an A in English, A in math example, all we need to look for is one of them to be true. Does that make sense? So if we see one thing is true, then the entire statement is true. Same thing with this one. Same thing with this one. This one. This would be like the one kid that shows up with crayons instead of pens or pencils, right? This would be false. He didn't do either one, okay? Does that make sense? Okay. So now, how does this help us? Well, let's see if we can figure this out. Someone says 10 is a natural number. 10 is a natural number. Is that true or false? True. So we're going to go ahead and we're going to say that P has a truth value of true, right? 4 is not greater than 1. What do you guys think? That one's false. Okay. So currently, P is true and Q is false. Okay. So now if we're looking at the first statement here, P or Q, what do you have to remember for an or statement to be true? One of them has to be true. Is one of them true? So the overall answer is that this statement is true. Okay. For B, now we have the negation of P, so you got to be careful. So what's this value going to be? This is actually false now, and this was false to start with, and we still have an or. So the overall answer here is false because you didn't have any of them be true. See if you guys can get the last three on your own now. Alrighty. So what do you guys think for the third statement here?
False.
That is correct. What about the next one?
True.
That is correct. What about the last one?
True.
That is correct. Are we getting it? Do we have any questions? If you don't want to ask now, please make sure you ask later when maybe you're not on the video. Okay. On to page 3. See, we're cruising. Now we're cruising. All right, so now the target here is to, like if we have a statement like these with some negations and there's a few more things going on besides just an or an and, but you have negations involved. Or even if-thens. We'll get to those tomorrow. But if you have more complicated statements going on, you can build a truth table that tells you all the outcomes that you can reference, okay? And so in order to do that, you have to list out every possibility. And so here's what it would look like, okay? So let's say we have a statement, a disjunction, P or Q. Actually, it's the negation of P or Q. You would say, well, we got two letters. We have one is P, the other is Q. And then what you would do is list out every possible thing. So I always start with true. P is true, Q is true. Another possibility is that P is true or Q is false. And now I say, all right, let's go through the false options for P. So P could be false, and then Q could be true, or both could be false. Do you guys see how those are all the options here? Okay? And so now what you're doing here, if you're building a truth table, once you know what P is, you could just look over here and you would know what the negation of P is going to be. Does that make sense? So the next thing you would do is write down the truth values for the negation of P. So just looking at the P column, what should this column be now? That's correct. Because if P is true, the negation is false. If P is false, then the negation is true. Does that make sense? Okay. And now here, so what we're doing is kind of building a step-by-step game plan along the way. Now that we know what the negation of P is, we can combine this into our final statement and figure it out. And now I'll use a different color. This is an OR statement. In order for an OR statement to be true, we need what? One of them or both, right, to be true. So what you're going to look at, though, is this column and the Q column. Right? So you're not looking over here anymore. Now you're just looking at your final product here. And so what is the final answer going to be? Final column. True? Yep. Good. True, false, true, true. Does that kind of make sense? Okay. Think of this as like deconstructing and doing things step by step, right? In other words, like when you see this statement here, before you can answer the whole thing, you got to figure out P and Q, right? If you know whether that's true or not, then you can certainly say, well, the negation is going to be false or the negation is going to be true. Okay? So same thing here. P, Q. You write down all your possibilities. And look, if you do a different order than I, not a big deal. This is just kind of my standard. I always do this order when I'm setting it up. Okay, but if you like flip your true, false, false, true, or you do it a little different, as long as each row is there, that's all I need. Okay? And so now, what should this column be if I'm doing things step by step? I know P and I know Q, so what could I do next in here? I can't negate yet. You got to figure out the value in here. If I know if the whole thing there is true, then I can negate it. If I know this entire thing is false, then I can negate it. Does that make sense? So your next column is to figure out P and Q next. Okay? I think once we do a couple, you'll start to see how these work. And so now we talk about what we learned just a few minutes ago. This is what kind of sentence here? And. And in order for an and sentence to be true, both must be true. So now you're going to look at this combination of P and Q, and when is the only time that that's true? First one. So the rest are false. And now that I know now that I know P and Q, my last column should be the negation of that. And all I do now is look at the column that is P and Q and flip everything, negate it. So the final answer, final column rather, should be false, true, true, true. Okay? Eventually what's going to happen is you'll have a truth table like this and someone will give you a scenario. Like, here's what the sentence was And now here's what Andy did. He did this, but he didn't do that. And then now you would answer, well, is it true or is it false then? Does that make sense? And once you have this built, you literally just go, oh, he did that but didn't do that? True. Okay? Everybody understand? Okay. Let's fill in real quick here. There's a blank. This statement contains 2 letters. So, and a good way to know how many rows you're going to need is this. Each letter has how many outcomes? It's either true or false. So with each letter, there are 2 choices, right? 2 times 2 gives us 4 total possibilities. Does that make sense? When we get down to this statement down here, this is going to be the fun one. Okay? We got 3 statements all combined. Each letter has 2 options. So how many total are we going to have? Whoop. We have 3 letters. Each one has 2 options. How are we getting that? 2 times 2 is 4. Times 2 is 8. You multiply the number of choices for each thing. So it's 2 times 2 times 2. If we had 4 letters, which we never will, but let's say we did, how many rows? You would need 16 of them. It keeps doubling. Okay? All right, so I'm going to do this one with you guys, and then I'm going to have you guys try a couple on your own here. And I think I don't need to keep recording the video after this because the rest now is just going to be you practicing in the notes. So let's go through this one. And let's write down our letters. So I'm just going to go R, P, and Q. And if you want to split them up into columns like that so it's easier to navigate, then go ahead and do so. Okay, and now here's kind of how so that I don't miss anything, here's how I make sure I hit every option. I start with 0 false. What would that look like? True, true, true. And then I go through every option with 1 false. So that means I could have a false at the end, or in the middle, or at the beginning. Does that make sense? So everything else would be true. Oop, that should have been a false right here. And now I go through my options of having 2 falses. So I could have still true for the first, but then 2 falses here at the end. And once you see this, it's easy to say, well, really it's the same case as saying 1 true, right? So put the 1 true here, put the 1 true there, make everything else false. And what's the last option? All false. Okay? Again, this is the standard order. Not necessary that you do it that way, but I think it's easy to remember. 0 false, 1 false, true false, all of them false. But if you have things shuffled around or slightly different than I do, then that's okay. All right. Let's talk about this, and then we'll fill it out. Looking at this statement right here, what's one thing I have to figure out? The negation of P. So I need a new row, new column just for that. And then what else? Negation of Q. So I need a row, or a column for that one. Once I know those values, what am I doing with those? It's an and. So now you merge them together and do a new column for that. And now that you know that, you can combine it with R or that column. Does that kind of make sense? Kind of. Let's write it out. So I'm going to have negation of P, negation of Q. Once I know the negation of each, I'm just following the order of operations basically. Once I know the negation of each, now I can figure out the and statement. So I'm going to combine it. Okay. And so now once I know this value, you're just going to focus on this column right here. You see how it's got R? or this column right here. And so that's what you would write in the final column. R or negation of P and negation of Q. Okay? Take a minute, fill it out. And if you're a little hesitant or still not sure, maybe use pencil and write lightly so that you can change it if we need to. But try it out first. This one? That's correct. And you should be looking for this column, you should be looking at these two. Both of these have to be true in order for this to be true. That's correct. So now you look R. You see how this last column merges these two with an OR? Yes.
So it's R or
Yes. You guys are making me so happy, by the way. This is what I want to hear. Working together, figuring stuff out. That makes me smile and feel warm and fuzzy on the inside. It cannot be two false. Sign out and grab the pass. All right, I'm going to start going through this. You guys tell me, what should the negation of P, that column, what should that look like?
False, false, true, false, true, true, false, true.
Everybody agree?
Yes.
These are pretty easy, right? Negation of Q, just flip everything in the Q column. So false, true, false, false, true, true, false, true. All right, here we got to be careful now, because if you make a mistake, typically it happens here. And if you make a mistake in one of the columns, you guys, that means your final column is going to have mistakes in it as well. So that means half your truth table is wrong because you got half of the columns wrong. Okay? So now what kind of statement is this? It's an and statement. But you are correct. In order for an and statement to be true, we need both to be true. So now we're looking at these two columns, right? And you got to see a double T, and that only happens twice, right here and right here. So that means everything else is false. Okay? Now the whole point of this is now here's our compound, our complicated sentence, right? We want to combine column R, which is this first one, or this column right here, the one that I just figured out. In order for an or to be true, we need one or both to be true, right? So looking at first row, that should be true. Here we got another true, true. Here we got a double false, so that won't work. We need one true. Here we're good. No good for the sixth one, no good for the seventh one, and then false here. Oh, wait.
Oh, no, it's true.
False true is true. Okay? Any questions on that? Yes?
So like, if we're going to compare our answers with like some other table, should we just like count how many truths and how many false we got?
That's a good place to start. That's a good place to start. Yeah, look at the final column. I mean, if you got your final column correct, definitely have to have the same number. So that's a dead giveaway right there. If you're not matching there, someone's off. Okay. All right.
Maybe we just rush them really quick.
Yes.
Is it not? These ones all